Very good. We're switching over to the quadratic formula only. No quadratic formula, no credit. So you have to do quadratic formula on this. A is 1, B is 8, C is 5. So we want to do our formula here. Now some of y'all get lazy and won't write your blanks. By the way, this fraction bar is all the way under everything, not just part of it. A is 1, B is 8, C is 5. Negative 8 plus or minus. This is 64 minus 20, that's 44. Of course, 44 is 4 times 11, and the square root of 4 is 2. So this is really like this. The whole thing over 2. So write giant fractions, separate fractions, negative 4 plus or minus root 11. That's a good answer on that one. Whoops, needed to move that up a little bit. So right here, when you got it, this 2 divides both directions. So when 44 changes to 2 root 11, this 2 is going to go there, and this 2 is going to go here. Very good. Come down to this one. A is 9, B is 6, C is negative 4. Negative b plus or minus the square root of b squared minus 4ac. The whole thing over 2a. A is 9, b is 6, c is negative 4. So this is 36. 16 times 9, that's 144. This is going to end in a 0. 180. Negative 6 plus or minus root 180 over 2 times 9, 18. Now for root 180, we're going to have to simplify that. So let's remember how we do that. We go over here to y equals, and we just do 180 divided by x. And then we want to go to the table. And I'm going to start up here. I'm going to look for the biggest perfect square I can find. Ooh, there it is. Look, 36. The square root. Think about this. The square root of 36 is 6. So 180 turns into 36 times 5, but the square root of 36 is 6. So we're going to pull a 6 out to the front. And while we're at it, let's change from a giant fraction over to separated fractions. So this is going to be negative 1/3 plus or minus. That should have been a 36 in there. I mean a 5 in there. I wrote 180 in there. That eraser's for really big mistakes. So this is root 5 over 3. Okay, so that's good on that one. And for on those two, and we'll be back. There were 7 and 8. Moving right along.